When a regulator, such as a Pest Management Regulatory Agency or the US EPA, looks at a registration of a pesticide, they take the toxicological data, they look at all of the toxicological data, and they take the most sensitive endpoint for the most sensitive species for a long-term exposure, usually the lifespan or close to the entire lifespan of the organism, and they calculate a no observed effect level. In other words, if that organism is exposed to that dose for its entire lifespan, not even the most sensitive response would be observed in that organism. And they use that to set a standard for or a guideline for human exposure. So they take that number, and it may be from a rat or a mouse or a dog or some other animal, and they say, okay, humans are not rats and mice, so we will put a safety factor or an extrapolation factor on that. And they're humans like me who are old, and they're young humans, and they're middle humans, middle-aged humans. And they put in another safety factor there of 10. So they're using two safety factors of 10, they multiply them, and they say, well, if this dose is safe for a rat, we'll say for humans, we will not tolerate a dose that's 100 times less than that. So we are given a good margin of safety or margin of exposure or an uncertainty factor that gives us additional levels of protection. And that's assuming that the humans are exposed in the same way as rats and mice, which is in the studies that are used to develop those values, is every day of the year for almost their entire lifespan, which for most humans would not be the case, except maybe a factory worker or somebody like that. So all of those margins of uncertainty, margins of safety give us an assurance that the levels that are set for maximum exposures in humans are protective of every possible eventuality, and that these chemicals can be safely used without experiencing adverse effects in the general population. It's really true that certainly now with the internet, you've got hundreds of thousands of places where you can get information, and there are many studies published, but one has to realize that studies are not all of equal quality or equally relevant. So what we need now more and more when we are looking at information generated under what's called good laboratory practices, which are required by regulatory agencies, say that register pesticides. Every study that a company submits to the EPA or the Pest Management Regulatory Agency in Canada must be conducted under good laboratory practices with quality assurance and quality control. And we have a GLP lab here in this building where I work that does those kinds of studies for registration of chemicals. And these are very carefully monitored studies. They're very carefully done. All the data are provided to the regulators so they can reanalyze the data if they want to. And it's very open and extremely transparent. Unfortunately, when papers are published in the literature, the standards of different journals vary, and the amount of information that's provided is very variable as well. In many cases, a published paper will not be accompanied by the raw data, so it's not possible to go back and reanalyze to see if the investigators actually did the right things to come to the conclusions that they came to. So what people are calling for now, and what's being written into regulations in Europe, in North America and other places, is what's called weight of evidence, where people look at the quality of a study, they look at the relevance of a study, and they then weigh the evidence in a very transparent and hopefully quantitative way, so they can say, well, these studies are not very good, and the results from these studies are not very reliable. These studies are much better, the results from these studies are more reliable. And when we look at the results in these two different groups of studies, we can then make a judgment as to whether whether there's a problem or not with the particular chemical. So if all the good studies say there's no problem, and all the bad studies show there is a problem, then obviously we must assume that the information from the bad studies is not good, and we should disregard it in making our decisions.